So today I'll be talking about Neisseria gonorrhea infections and the related human immune response. So just as an introduction to the pathogen itself, Neisseria gonorrhea is a gram-negative diplococci bacteria that was originally isolated by Albert Neisser in 1879, and it is the causative agent of the disease gonorrhea, which is a venereal disease or sexually transmitted. It's considered endemic in many parts of the world, and the CDC most recently reported there being 3 million cases in the last year domestically in the United States. There's also major concerns caused by rising strains with high antimicrobial multi-drug resistance, but that's not something we'll cover in this presentation. The transmission of the bacteria itself relies on sexual activity by people. This is partly because the bacteria is an obligate human colonizer, meaning that it cannot survive outside of the human host. The transmission itself relies on the attachment to sperm, meaning that men to their sexual partners observe the highest amounts of transmission, and this is through their ejaculate. So women to men, and that transmission is a lot less understood, and this is thought to be because there's actually needs to be a lack of sialic acid on the surface of the bacteria if it is to infect the male urethral epithelium. But once successful transmission occurs, the infection of the host tissues by the bacteria relies on a stepwise process, first involving adherence, which requires the type 4 pili and opoproteins, with the type 4 pili operating most of the bacteria's actual mobility, and the opoproteins binding to surface features of the epithelium, like heparin sulfate. After successful adherence, there is colonization and invasion, which begins with microcolony formation and then moves towards cellular signals between things on the bacterial surface like porin and lipooligosaccharide to actually invade the host tissue through transcytosis. Before we get into the different ways that the immune system responds to this invasion, we first go over this phenomenon of symptomatic versus asymptomatic infections of gonorrhea. For the most part, in general, infections are asymptomatic. This is especially true in the women population. And although it was the long-held dogma that male genital infections were almost always symptomatic, it is now becoming more and more understood that there is still a significant percentage of asymptomatic infections observed in the male population as well. So these asymptomatic infections are specifically a problem because if they remain asymptomatic for long enough, the bacteria will avoid any sort of treatment, and these can lead to serious health complications. Returning back to this idea of purulent exudate, it's one of the only symptoms that allows for clinical diagnosis and is sort of the hallmark symptom of symptomatic gonorrhea infections. This purulent exudate is actually a combination of neutrophils found at the site of infection and the bacteria itself. And why there's so many neutrophils in this discharge, we'll get into in just a sec. First off, though, going over the way the innate immune system interacts with the pathogen, the Neisseria gonorrhea presents a very apt capability to evade, in general, host immune responses. In the context of innate immunity, this is especially true for the complement pathway, where Neisseria gonorrhea can actually evade both the alternative and classical pathways. In the case of alternative, it does this by cleaving C3b complement protein attached to the lipid A of its LOS on its surface with a reaction including factor I, which leads to the inactivated version of complement protein C3b being bound to the pathogen surface. This prevents opsonization across the entire bacteria, meaning that there is not any more efficient phagocytosis happening after such occurrence. The classical pathway is actually avoided by sialylated LOS and porin binding both factor H and C4b, very similar to factor H, both of which present the bacteria to be a part of the self to the innate immune system, which obviously isn't true. But in general, after avoiding both of these forms of complement, the bacteria is able to avoid phagocytosis via opsonization and lysis via the formation of any sort of membrane attack complex. When it is detected by the innate immune system, that would be because of PAMPs present, such as the lipooligosaccharide and peptidoglycan, which are capable of triggering innate immune sensors, such as toll-like receptors 2 and 4 in an extracellular scenario, and NOD1 and 2 receptors, assuming that the pathogen was phagocytosed. After phagocytosis, tissue-resident macrophages can secrete pro-inflammatory cytokines and chemokines, such as interleukin 6, 8, 1 beta, 17, and interferon alpha, as well as leading to the expression of nuclear factor kappa B. Among other things, this leads to an influx of neutrophils to the site of infection, which will also further phagocytose the bacteria. The problem is, in a scenario where Neisseria gonorrhoeae has been phagocytosed by either a macrophage or a neutrophil, it can from this position modulate both the innate immune responses of those two types of cells, while also modulating the adaptive immune responses. And we'll get into how this occurs a little bit more in just a sec. First, though, we'll go over another form of innate immunity that is triggered by Neisseria gonorrhoeae infections, and that's TIFA-dependent innate immunity. This is triggered by the cytosolic release of heptose 1,7-bisphosphate, which is actually a metabolic intermediate involved in the synthesis of the lipopolysaccharide. But once this molecule is present in the cytosol, it binds to the TIFA protein, which stimulates the phosphorylation-dependent formation of the tifosome, which can then further stimulate trap proteins and eventually lead to even more expression of nuclear factor kappa B. So as you can see, there's a robust innate response to Neisseria gonorrhoeae. But the problem that we face is there is little to no adaptive immune response. The main reason that this happens is because of that modulation that occurs at the site of infection, which includes dendritic cells. Dendritic cells that are exposed to Neisseria gonorrhoeae can actually no longer stimulate T cell proliferation, specifically CD4 positive T cells, into any form of helper T cells. And as you can imagine, among other complications, this leads to little or no differentiation of any B cells or further development of more effective antibodies through something like isotype switching. Because you don't have this differentiation as a result of no T cell proliferation, you have no formation of memory or plasma B cells, which leads to no secondary response if there was to be a secondary Neisseria gonorrhoeae infection. On top of this, there is significant antigenic and phase variation of surface features on the bacterial surface, such as with that type 4 pili. The type 4 pili could act as a protein epitope that could be presented on MHC molecules of antigen presenting cells to T cells. But because they vary so much, you actually never see an effective presentation and further activation of T cells, not to mention the fact that the dendritic cells themselves cannot lead to any sort of T cell proliferation for a more effective T cell based response. So where does this leave us? It's almost as if there's a missing infection, at least in the sense of the adaptive immune response, right? If we think about it from a symptomatic perspective, the purulent exudate that is caused by that actual influx of the neutrophils to the site of infection is one of the only diagnosable signs of an infection at the microscopic scale. At the microscopic scale, there's very little evidence of there being any adaptive immune responses. So it's much harder to detect Neisseria gonorrhoeae after it's successfully infected any sort of tissue. The other significant problem with this purulent exudate and the way that the innate immune system responds to Neisseria gonorrhoeae infections is we're actually not even sure if this influx of neutrophils is something that is just working to the bacteria's advantage. Because if it creates this discharge in the form of this exudate, there is belief that it is expelled with excess neutrophils and actively replicating Neisseria gonorrhoeae bacteria that could just give it a transmission advantage. So with a lack of adaptive immune response to really fight off these infections and no memory formation, there's a lot of times these really long-lasting infections that can lead to extensive damage if they go untreated, especially if they're asymptomatic. And on top of that, individuals can be repeatedly infected with Neisseria gonorrhoeae over and over and over, regardless of the treatment they seek or receive. So we hope that there will be some development in either the treatment or the understanding of the way that Neisseria gonorrhea interacts with our immune system so that people do not have to suffer long lasting asymptomatic infections leading to complications in their health.